This tutorial solves problem 20.28 from the book, and it's primarily looking at the population decline of 3 organisms in a lake water. And there's a model, exponential model, that uh, describes their decay. And given some data, which is time at various hours and the population at those times, and these could be uh, the units are not given, but these could be thousands or millions or per some unit volume of the lake water. And so we are to find out the parameters A, B, C, which are technically the initial population of these 3 organisms. So if we look at this model, this is a nonlinear model, but it is linear in the parameters, which means it's a linear combination of these exponentials, um, and so we can find A, B, C using the linear least squares estimation. And so if we look at the plot of the data, we can see it's an exponential decay. And now we can create a matrix, which is the 3 exponential values. So these are the 3 columns that correspond to these 3 components of the equations, and A, B, C is the parameter, which is the column vector that is next to this A matrix. So in order to find P, we can find the pseudo inverse and multiply it with the population column, and this gives us the initial values of the population of the 3 organisms. And now we can also find the value of the population fit and plot it, and you can see that the red x's are much closer to the data points. And so we can also create a function which is a function of time, and so this is p1 times the first exponential plus p2 times the second exponential and plus p3 times the third exponential. Let's move this out of the way, and now we can hold on and put an easy plot of f on it. It looks like our range is from 0 to 9, so we'll stick with that range, 0 to 9. Hold off. So this will put the curve on it. So you can see that our model fit very closely passes through the data points.